Hello, welcome to the online video lecture series on electromagnetic waves. In this video session, we are going to do a small revision because you might have studied about vectors and the coordinate systems in your school days itself, in the school day physics. Just a small revision on vector calculus. Okay, that is what I am going to do. So, in the last class, we discussed the reason for difficulty when you deals with electromagnetic waves, that is wireless communication, that is handling the parameters voltage and current is not that much difficult when you compare to handling the parameters electric field and magnetic field. Reason 2. Number 1, it deals with vectors. Number 2, it deals with location, what is it called? Coordinate systems. So today we are going to discuss about these two fundamentals, that is about the vectors and as well as about the coordinate systems. So we classify two major physical fundamentals parameters as scalar and vector. A general definition which you know. Any physical quantity represented in terms of magnitude only. I told already, please make the notes. Any physical quantity represented in terms of magnitude only is defined as scalar quantity. Any physical quantity which is represented in both magnitude and direction is defined as vector quantity. Scalar means only magnitude, vector means both magnitude and directions. So usually if you ask example for scalar, people used to say weight, temperature. Example for vector, acceleration, velocity. Good, perfect. But you are in electromagnetic waves, you are in engineering. Tell our own example. Example for scalar, voltage and current. Let us use our own example. Example for vector, electric field intensity E, magnetic field intensity H. Okay. This is the example for vector. So please remember the definition of the scalar, it deals with only magnitude. The definition of the vector, it deals with both magnitude as well as directions. We have given some examples also. Okay. Now let us do some mathematical calculations called product with respect to a scalar and a vector. Number 5 is a scalar. Number 3 is a scalar because it's only a value, magnitude. 3ax cap, which means vector. 3 is the magnitude, ax cap is the direction. Please remember, what is the definition of the vector? It is a quantity which has both magnitude as well as direction. What is the magnitude? 3. What is the direction? Ax cap, x direction. It is in x direction. 6az cap, which direction? Z direction. What is the magnitude? 6. A y cap. What is the direction? Y direction. What is the magnitude? 1. Please don't say there is no magnitude. The magnitude is 1. Since the magnitude is 1, it is called a vector, unit vector, because its magnitude is 1. Now I can say P is the vector, Q is the vector, A is a scalar. A, there is no arrow mark. Okay. So if it is a scalar, it has only a number. If it is a vector, it has number as well as the direction. If number is not there, its direction is, its magnitude is 1. If I want to multiply 2 scalar, result is a scalar. 5 into 3 is 15. Multiplication of 2 scalar, I don't want to discuss in my engineering. This is 3rd standard work. Why I should discuss? I am sorry. Multiplication of 2 scalar is not my business. Multiplication of 2 vector, that is my business. Please remember. What is vector? I am going to do multiplication of 2 vector, that is 3ax cap multiplied by 5ay cap. What is the result if you multiply? That is my engineering. Okay. Please remember. Now whenever I multiply 2 vector, how to do the multiplication? Some categories there. One is dot product. Other one is cross product. Now, what do you mean by dot product? What do you mean by cross product? Dot product is A dot B. Cross product is A cross B. Most of the time our physics teacher and our maths teacher will try to tell you just formula. But my duty is not that. Formula you can learn anywhere, just by hearting. A dot B equal to magnitude of A, magnitude of B, cos theta. A cross B equal to magnitude of A, magnitude of B, sin theta. N cap. This is the formula for dot product and cross product. Just if you remember this, don't say, I am sorry to say this, don't say or don't jump, I know dot product, I know cross product. Now my question here is, who is A and B? Who is A and B? Easily will get cheated by the definition. Dot product is also called scalar product. Cross product is also called vector product. Everything we studied in our PUC, that is the school days. The moment you see this, suddenly what we will discuss? Scalar product. Sir, A and B is a scalar. Vector product. Sir, A and B is a vector. Stupid statement. Serious, listen. Scalar product, which means multiplication between 2 scalar. Just now I told multiplication between 2 scalar is a school day mathematics. Why I should discuss that today? I am sorry, my dear. Sincere, serious, listen. Who is A and B? Vector. Who is A and B? Vector. 200% all are vector because my subject is vector. Why I should study scalar? It was in the school days. I told already. Now the question. Who is dot product? It is between 2 vector. Who is cross product? It is also between 2 vector. It is product between 2 vector. It is also product between 2 vector. You mean to say no difference? No difference. Both are between 2 vector. So what is the difference? It is between 2 vector. Result is a scalar. It is between 2 vector. Result is a vector. Scalar result of the product. Vector result of the product. Please try to answer me. What is cos 45 degree 1 by root 2. Is it a number? Yes. A number is a scalar. Now try to answer me. Who is cos theta? Magnitude, number. Magnitude of B, name itself says magnitude. Magnitude, come on. Who is he? Magnitude, magnitude, magnitude. Are you seeing any direction here? No. All are magnitude. It is a scalar. Magnitude, magnitude, magnitude. Direction, n cap, direction. It is an arrow mark is there. Okay. What is this? We will discuss later. So who is he? Vector. So please remember. Who is he? Vector. Who is he? Scalar. Now if somebody asks, what do you mean by dot product? It is between two vectors and the result is a scalar. What is cross product? It is between two vectors and the result is also a vector. Please remember this. This is the fundamental statement. Please try to recap. Dot product between two vectors. Cross product between two vectors. Its result is a scalar. Its result is a vector. Now if you have A one vector, B one vector, the angle between A and B is that cos theta sin theta. Okay, this is the mathematical discussion. Let's not bother. Sir, the result is a vector. The vector is in which direction? If A is in x direction, B is in y direction, this is the plane where A and B is available. Now for this plane where A is here, B is here, in this plane perpendicular is nothing but your result. So in engineering I won't use the word perpendicular, I will use the word normal. So n stands for normal. For this plane perpendicular is the result. This is called n cap here. Okay, so what is the n cap says? It is a direction. Result is a direction which is perpendicular to, normal to plane containing A and B. Please try to remember. So, who is a dot product? Sir, it is between two vectors. Result is a scalar. Who is a cross product? It is between two vectors. Result is also a vector. Now someone is coming and saying, sir, V is equal to E cross H, sir. You should say, stupid, absolutely wrong. Why? Sir, E is a vector, H is a vector, it is a cross product, result must be a vector, but you have given voltage which is a scalar. Because the cross product says result must be a vector. Del dot D equal to rho V. It is one formula, later we will derive. Del is a vector, D is a vector. Like this. Can you please say whether it is right or wrong? Good. It is wrong. Reason. Which product? Dot product. Between two vectors. Del. What is this symbol del? We will discuss later. Del is a vector, D is a vector. Result must be a scalar. But I made an arrow mark, so it is wrong. So strictly speaking, this is a scalar. Okay. When I write down this particular formula, it should be del dot D is equal to rho V, scalar. Actually, this formula, actual formula is last session I might have made vector. Okay. So dot product between vector, cross product between vector. Result is a scalar, result is a vector. So what is the definition of dot product? It is product between two vectors and the resultant is a scalar. It is product between two vectors and the resultant is a scalar. Definition of cross product. It is product between two vectors and the resultant is also a vector. Okay. So please try to remember this. Okay. So I have written some vector identities. These are all one of the fundamental formula which you might have derived this in first year maths. I hope M2 somewhere you might have derived most of the mathematical terms which I have mentioned here. In my subject, you should remember these 6 statements, 1, 2, 3, 4, 5, 6 statements. There is no derivation here, okay? But I will give you some explanation about these statements, okay? Better try to do that, but before that, it is cross product between two vectors. Remember, A is a vector, del is also a vector, okay? So A is a vector, cross product Dot product is also between two vectors. A is a vector, B is a vector. Okay, I would like to always mention that. A is a vector. V is a scalar. Okay, so V is a scalar. I am not going to mention. So let us try to maintain A, B, del are vector. Okay, and V is nothing but scalar. Just try to pause this particular video and try to copy all this particular result first. Okay. Next, be serious. More detailed discussion, and sorry, it is inside your subject in module 1. We will do it later. More detail. Today, only a preliminary discussion. Don't say, sir, I am not that much understanding your concept, sir. Please, okay, just a temporary things. Who is del? Later, I will give you definition itself. Please remember, I will give you definition. Del says variation. Okay, del says change, variation. It is a vector, okay, but I am not going to write down because it is understood. Name itself vector operator del. So name itself vector. So I no need to mention. And please remember whether I am changing or I am constant. I am constant. Now changing. This is called variation. Variation in x direction. Variation in y direction. If I go up, variation in z direction. So if I start changing like this, variation is there with respect to direction. Mathematical representation for a variation is differentiation, partial differentiation. So del is nothing but dou by dou x x cap. Please don't get shocked. This is a derivation which I will do it later in module 1. Today only a preliminary discussion. Please remember, I am repeatedly saying that. Don't get shocked. Direction is there. Okay, direction is there. So who is a del? Direction. What del says? Good. What del says? It says variation with respect to direction. It is a vector. Okay. If you want to make a note, del is a vector operator. Del is a vector operator which says variation of a quantity with respect to direction. Okay. Keep it in mind. Now carefully listen. If I say A dot B, it is between two vectors. If I say A cross B, it is between two vectors. If I say 5 into A direction, this is between two vectors. No, 5 is a scalar, A is a vector. So, multiplication between two vectors, multiplication between two vectors, multiplication between a scalar and a vector. Between two vectors, result is a scalar. Between two vectors, result is a vector. Between a scalar and a vector, result is also a vector. Okay, please remember. Now carefully listen. If I multiply between two vectors with dot product, you call it as dot. Okay, what it is called? Dot product. If you multiply between two vectors and the result is a vector, means we can also call it as cross product. One vector and one scalar, we call it as product. It is a general name. Okay, please remember. 5ax cap. Okay, this is the name. Now carefully listen. Two vector dot product. Two vector cross product. Result is a scalar, result is a vector. Vector and a scalar is called a product, result is a vector. Carefully listen. Out of two vector, if one vector is del, Out of two vector, if one vector is a del, instead of this vector, if that is a del, then instead of a del, then can I call it as a dot product? Yes. Can I call it as a cross product? Obviously yes. Can I call it as a product? Yes. But there is a special name is there called divergence. There is a special name is there called, in area which you might have studied in physics, curl. There is one special name for this is called gradient. Okay, please remember divergence, curl, gradient, each and everything is one title. I will explain you very clearly inside the subject later. Today only introduction. Out of two vector, if one is a del, it is a divergence. Out of two vector, if one is a del, it is a curl for cross product. If this is a vector, then it is a gradient. Okay, please remember. What do you mean by del? Variation, change. Divergence is a variation, expanding variation. Okay, take a balloon, fill it with air, try to break, it expands. Okay, divergence. Take a water, put just water in a bucket and try to rotate, it rotates. Curl, circulation. It is also a variation, circular variation. This is gradual variation. This is expanding variation. Okay, please try to keep it in mind. Now try to answer me. Who is it? You can say cross product? Yes. But what is special name? Curl. What is the one is del? What is the special name? Divergence. So, divergence of a curl. I hope you are getting. Divergence of a curl. Curl of a gradient is 0. Curl of a curl. Dot product between the cross product. Dot product with general scalar. That is called the gradient. Like this we are going to define. Who is he? Gradient. Who is he? Curl. Who is he? Curl. Who is he? Divergence. Okay, please try to remember this. Please try to make a note of that. With this, let me conclude this introduction to the